Okay, so today we transition. We're going to transition into our introduction to computer science. So we're starting chapter 3. And how cool of a subject is it that you get to, transition from quantum mechanics, quantum information into computer science? So our key notion in this chapter will be that of an algorithm, which I hope you're familiar with. I'm just going to have it as a precise, call it a recipe, precise recipe for performing a task. Okay, so hopefully familiar. We're going to ask some key questions about algorithms, and we're going to see how they differ between classical and quantum models of computation. So some of our key questions are going to be, what resources does an algorithm require? What resources, including both space and time, does a given algorithm require? And, in some cases, in general, this is going to be hard, but in some cases, we can give lower bounds for certain tasks. In other cases, we'll be able to be more precise, and we'll look at explicit algorithms for other certain tasks. So the algorithm is going to be underlying all of chapter 3, all of computation. And we're going to define some models to be able to analyze algorithms. Just looking ahead, the two ones are going to be Turing machines. That's what we're going to cover today. And this is more abstract, but still a valid model of computation. And the second one that we'll cover is the circuit model, which probably you're more familiar with. So that is using individual bits, processing through time with certain logic operations. But today we're going to start with so I'll write that down, our models for computation. The first one is going to be a Turing machine. That's what we'll do today. And then the second one, next time we'll pick up with the circuit model. And in a lot of ways, this one is more intuitive, more useful. And this is actually the one that we'll use for the quantum model of computing. So we'll have quantum circuits, which we've gotten foreshadows of.